This is the fifth section in the Matrices chapter core 1, and this is about how to find the inverse of a 3 by 3 matrix. Now, before I show you the method, I'm actually going to show you how you can do this on a calculator, because it is acceptable unless they want you to show particular steps or show particular matrices, like the matrix of minors or the matrix of cofactors, which we'll talk about in a moment. You can do it on your calculator because there are a number of steps. It does take a while to do it, so we'll just put down how we do this on a calculator. Right, so on a calculator you're going to press menu, and from menu you are going to choose number 4 and then press equals. Equals is like your enter. Then you'll need to define a matrix. You can choose 1, 2, 3 or 4. So I'm going to choose 1 to define a matrix. Then I'll put in a number of rows and columns. That's going to be 3 and 3. So after that we'll just put 3 and 3 to get 3 times matrix. You type in what the elements are of your matrix to get matrix A. Now if you press option, there is no option for an inverse. So what you have to do is you need to bring the matrix up, and the way that you do that is to press the OPTN button. Okay, and that gives you options to what you can do with your matrix. You're going to pick either 3, 4, 5 or 6. So since I did matrix A, that's going to be 3. Obviously it'll be different if you choose matrix B, C or D. So I'll bring up my matrix. It says matrix A. Now from here I'm going to press the x to the -1 button like this, yeah, which is underneath your x squared button. So if I press that button directly afterwards, I'll have on my screen, it will say something like mat A, like that, with a little -1 there. If I press equals, it will give me the inverse matrix, yeah, so then I'll get the inverse of A. Now if, for example, you get a matrix full of decimals, if you use your cursor button, hover over an element, it should come up with what that element is as a fraction. You can use the SD button as well. So that's just how you go for it using a calculator. Right, let's get on to how we do this manually. Okay, none of this is in the formula book, so you do need to remember them. So the first step is to find the determinant of A. So you need to find the determinant of our matrix. So this is about finding the inverse of, we'll call our 3 by 3 matrix A. So determinant of A, we know how to work out the determinant of A. That's what we did in the previous section. So just as a reminder, for a 3 by 3, the determinant is, remember, you need some minors of particular elements. So the determinant of A is going to be A times the determinant of its minor, which is going to be the elements E, F, H, I. So here we're talking about a 3 by 3 matrix. It's A, B, C, D, E, F, G, H, I here. Okay, so there's our matrix A. Determinant of A, so element A times by it's the determinant of its minor. Minus, don't forget there's a minus there. Element B times by the determinant of its minor, which are the elements D, F, G, and I. So remember, to get the minor, you cross out the elements in the row and column of that element, plus element C times the determinant of its minor, and that will leave you with D, E, G, H once you cross out the values in the row and column. So that's step number 1, is to find the determinant of the matrix, which we've done before, I think in section 6.3. Step number 2, now what we need to do is we actually need to find a matrix of minors. What's matrix of minors of A? Matrix of minors of A. Now what that means is, for every element in the matrix, I need to find its minor. For every element in the matrix, I need to find its minor. So for example, where element A is, so let's just show you that up here. Where element A is, I would replace it with its minor, which is going to be the determinant. Well, I'll probably write it down before working out the determinant, but where A is, I'll put a bar, EFHR bar, yeah, which means afterwards I'm going to work out the determinant of that. For element B, for example, once I've crossed out the elements in a row, in every row and column of B, then where B is, I'm going to replace it with bar, DFGI bar, yeah, like this type of thing here. And then I do the same with elements C, D, E, F, G, H, and I. So what I'll end up with is like 9 of these things here in a big bracket, all with different numbers in, because we're moving around the matrix as we cross out things in each row and column. And that's going to be called what we call a matrix of minors. And from each of these little things here, we're going to work out the determinant. So for every element, we need to work out the determinant of its minor. That's probably the most working you'll have to do in this particular type of question. And the matrix of minors, we use the letter M. I know we've been using letter M before for matrix, but it'll normally be find the determinant of, find the inverse of a matrix A or B. They won't usually say find the inverse of a matrix M, because we're going to be using M to stand for this matrix of minors. Part 3, third step. Right, okay, we now form what we call a matrix of cofactors. Matrix of cofactors. And the way we do that is that we're going to reverse the sign of every other element, starting with the second one. So basically all the even positioned numbers or elements in a matrix, we're going to reverse their sign, and others we're going to keep their sign. Now we use the letter C to stand for this matrix, and basically what it's going to look like is this. So this element here, we leave its sign unchanged, reverse this sign, keep that sign, reverse this, keep, reverse, keep, reverse, keep. Yeah, so you can see that these elements, those elements in those positions here are going to get their signs reversed. Yeah, that form that sort of cross shape, and that's called the matrix of cofactors, and that's from the matrix of minors. Okay, so after you've done step 2, you use that matrix to find what we have in step 3. Yeah, so we found our matrix of minors, then from that we find a matrix of cofactors. This is called the rule of alternating signs, and I think you can work out why it's called the rule of alternating signs. And then what we do with our matrix of cofactors is that we now need to find the matrix, what we call the transpose matrix. So we now need to find the transpose of C, and C was this matrix of cofactors. Now the way we show that is C with a little t at the top. And how do we find a transpose? It's actually written here, so it's just handy, just where I've written it. The transpose of a matrix is found by swapping basically the rows and columns, interchanging the rows and columns. So the first row becomes the first column, second row becomes the second column, and so on. Yeah, so you change each row and column. The only element that's going to be in the same place is going to be element A. So I suppose, you know, if we started with A, B, C, D, E, F, G, H, I, okay, then the transpose of that is going to be A, B, C, D, E, F, G, H, I. So you can see how it works. The rows become columns, the columns become rows. And then we're almost done. Step number 5. The inverse of the matrix, so A inverse, is equal to 1 over the determinant of A. Now that's the same as the 2 by 2 times by the last thing that we just did, the transpose of the matrix of cofactors, which came from the matrix of minors. So there's quite a few steps there. Now, if you've got some time, actually apply this method to a 2 by 2 matrix and see what happens. Apply this method to a 2 by 2, and what you'll find is this actually finds the inverse of a 2 by 2, but a lot of these steps sort of basically boil down to swapping over A and D, reversing the sign of B and C. So it's like almost like the cofactors thing. That's why we reverse the signs of B and C. Yeah, you can see like a little matrix there. The transpose bit, well, that's where the A and the D sort of get swapped over. Yeah. So if you were to do the transpose of a 2 by 2, the matrix of minors thing there sort of it all gets tied in with the determinant. That's why with a 2 by 2 it's just 1 over the determinant times by A and D swapped over and the signs of B and C reversed. But you could apply all of this, but we can make it much easier with a 2 by 2. Right, so we're going to find the inverse of this matrix here. So the first thing that we need to do is we're going to find the determinant of A. So the determinant of this matrix. Now remember, that is equal to element A times by its minor, or which is going to be, if I cross out in that row and column, I get 4, 1, negative 1, 0. Let's make it a little bit tidier there. So 1 times its minor, 4, 1, negative 1, 0, minus B times its minor. So that means crossing out that and that. So that will leave me with 0, 1, 2 zeros. So I'll get rid of that. And then element C times its minor. So we'll cross that out. So plus element C, which is 1, 0, 4, 2, negative 1. Okay, so let's work out what this is. This will be the determinant. So I get 1 times by 4 times 0 minus 1 times 1, which is basically 1 times 1, minus 3 times 0 minus 2, so that's 3 times negative 2. Then I'm going to have plus 1 times basically negative 8 times negative 8, because I'm just going to have 0 minus 8. So that will give me 1 plus 6, which is 7, minus 8. So I get a determinant of negative 1. Okay, so that's step number 1. Step number 2, I want to find this matrix of minors. This is going to be quite big, so you're going to need yourself lots of space. So for every element, I'm going to write down what its minor is. Now I've already got the minors of elements A, B and C because I needed that for the determinant. So let's write those down from what we've got above. So 4, 1, negative 1, 0, 0, 1, 2, 0, and 0, 4, 2, negative 1. So those ones I can just copy down. I just need to do the same for the remaining elements. So element D now, cross out what's in that row and column of that one. So that gives me, I need the minor of 3, 1, negative 1, 0. Element D. So it's element E, I think that one. A, B, C, D, E, yeah. So that'll be, its minor will be 1, 1, 2, 0. And then element A, B, D, C, D, E, F. This one. So that will be 1, 3, 2, negative 1. Now we move to the bottom row. So this element here, so its minor will be 3, 1, 4, 1. You can see there's lots of places where you could make mistakes if you're not careful because there's so much little fiddly bits we need to do. This element here, so we cross out what's in the row and the column, 1, 1, 0, 1. So 1, 1, 0, 1. And then the last one, if I cross out what's in the row and column of that last element there, I'm left with 1, 3, 0, 4. Okay, so what I now need to do is work out what these are. So remember those bars mean the determinant. From each one of these now I need to work out what the determinant is. Right, so the first one is going to be 4 times 0 minus negative 1, so I get 1. This one here, don't normally do these questions so you end up with like lots of zeros to make things a little bit easier. So the second minor, 0 minus 2, so it's going to be minus 2. Third minor is going to be negative 8. Fourth minor is going to be 1 because you'll have 0 minus negative 1. Fourth minor is just going to be negative 2. Not fourth, 1, 2, 3, 4, that fifth minor. Sixth minor, where you've got a 1, 3, 2, negative 1. So that will be minus 1, minus 6, so we'll get minus 7. Bottom row now, the minor of 3 times 1, so 3 minus 4 is negative 1. Then 1 minus nothing. And then the last one will be 4 minus nothing, so 4. So there we go. This is M, the matrix of minors. So can you see how much work we do? It is very easy, if you're not careful, to easily make a mistake. Right, we now find the matrix of cofactors, applying the alternating signs. So let me just write over the top of them. So plus, minus, plus, minus, plus, minus, plus, minus, plus. That's right. Yeah, if I want a cross shape. So from there, I'm going to get matrix C. Should underline these really, because these are matrices. And I just reverse the signs of the elements which have the minus sign over the top. So what I might do, actually, because that's not 100% clear with that thing over the top, like that, I will just put, I'll highlight the elements which signs need changing, and that's going to be this one, this one, this one, and this one. The other signs don't change. So what I will get is 1, 2, negative 8, negative 1, 2, 7, negative 1, negative 1, 4. Yeah, so now I have that, the matrix of cofactors. So from here, I now need to work out the transpose of that matrix. So I might just have enough space, which means you change the rows and the columns. So the top row becomes the first column. So 1, 2, negative 8. It's probably easier to do this like this. Second row becomes the second column. So negative 1, 2, 7. And the bottom row becomes the last column. Negative 1, negative 1, 4. Okay, so just about had enough space. That's this transpose. And then inverse, we're almost done now. The inverse is now equal to 1 over the determinant, 1 over minus 1, times by that transpose matrix. So 1, negative 1, negative 1, 2, 2, negative 1, negative 8, 7, 4. So we can actually work that out by just multiplying everything by negative 1, which means just reversing the signs of everything. So we get negative 1, 1, 1, negative 2, negative 2, 1. In the bottom row, 8, negative 7, negative 4. And then what you can do is you can use your calculator to check to see if that answer is right. Okay, so check on calc. And if you had loads of time, what you could do is you could check by doing A times by its inverse, and you should get the identity matrix. So you should get 1, 0, 0, 0, 1, 0, 0, 0, 1. I'm not going to do that here, but you can do that, and that's just to show you actually that this working out this inverse actually works and it does what it's meant to do. Okay, so on this question here, we're asked to find the inverse of a matrix, 3 by 3 matrix, but notice that we have this element here, which isn't a number, it's just given as k. So our answer is probably going to be given in terms of k, but we do exactly the same steps. So step number 1, we want to find the determinant of this matrix. So it's going to be 3, the first element, times its minor, which is k 0, negative 3, 3, minus the element 2 times its minor, which is going to be negative 2, 0, negative 1, 3, and then it's going to be element negative 2, so plus negative 2 times its minor, which is going to be negative 2k, negative 1, negative 3. Okay, so let's now work out what the determinant is. So we basically have, just put the arrows in so you can see what we're multiplying with, that times that, and so on for each one, like that. So first one is going to be 3 times by 3k take away 0, which is just 3k, minus 2 times by negative 6 times by 0, so it's just going to be negative 6, 2 times by negative 2 times by negative 6. Let's put that in, times by negative 6. And then basically the plus minus 2 just becomes minus 2 times by, and its minor will be 6 minus, or 6 plus k, 6 plus k, because you've got negative 2 times negative 3, which is 6, and then minus negative k becomes plus k. Right, so what does that give us? So we have 9k, and then we have plus 12, then from expanding this over here, we get minus 12, so it looks like the 12 is gone, minus 2k. So actually, all of that just becomes 7k. Yeah, so the determinant of that 3 by 3 becomes 7k. Now, if this was an exam question, there'd probably be a part B that says something that gives you some extra information that would allow you to work out what k is. So it might say that k is singular or something like, oh, the matrix is singular, to allow you to work out k, something like that. But it's not so in this case, it's not singular because you can find the inverse. Right, next step after that, this is the long step, which is to find the matrix of minors, which we'll call M. So this is going to be working out the minor of every element. Now the first three we already have. Now actually what we could do, we need to work out the determinant, don't we, of the minor is working out the determinant. So actually we've already got what the first one is going to be. We've already got what the second one is going to be. We've already got what the third one is going to be. So what we could do, an option is to actually write 9k, 12, negative 12, minus 2k. We could write that down, but I'm going to just write the minors down, and then I know I've got the answers for that for the next section. So this one we already have, k0 minus 3, 3. Then we have negative 2, 0, negative 1, 3. And the last one, like top row, negative 2k, negative 1, negative 3. Going down to the second row, so I want the minor of this. So that's going to be k0, negative 3, negative 3. Oh no, sorry, that's not right, is it? The elements I cross out are this one and this one. Thought that didn't look right because I was thinking I had that written down already. So that's going to be 2, negative 2, negative 3, 3. Then we'll move on to the element which is k. So we'll cross out this, we'll cross out this, and we'll have 3, negative 2, negative 1, 3. And the last one in that row, so we'll need to cross out that and that. And it gives us 3, 2, negative 1, negative 3. Oops. So now we move on to the bottom row. So cross out those for the negative 1. I'll probably need to make my bracket a bit bigger. Let's do that in a minute. So that gives me a minor of 2, negative 2, k0. Well, not actually the minor, but the elements to allow me to work out the minor. Then we move on to the negative 3, so cross out those. So 3, negative 2, negative 2, 0. And then the last element, the 3, cross out those, gives me the elements 3, 2, negative 2, k. Right, so we want to work out what all of these are. So determinant time. So the first one is going to be 3k, because I ended up doing 3 times k minus something times 0, so 3k. Second element is going to be just negative 6, because we end up doing 0 times negative 1, so negative 6. The next one is going to be 6 minus negative k, so 6 plus k. Next one, going down to the second row, 6 minus 6, 6 minus 6, yes, that's 0. Next one, that's a 3. I thought it was going to be an 8, that's a 3 I wrote there. So that's going to be 9 minus 2, so that'll give me 7. Next one will be -9 minus -2. So that's -9 plus 2, which is -7. Bottom row, 0 minus -2k, so that just becomes 2k. Positive 2k. Next one, I think that's a 0 I've written there. Let me just check elements. Yeah, that should be a 0. Can't read my writing. So 3 times 0 minus 4, so that just becomes -4. And the last one, 3k minus -4, so 3k plus 4. Okay, so there's my m. From there, I'm going to find c, so that's the cofactors. So I only need to reverse the signs of this one, this one, this one, and this one. So obviously the zero's not going to make any difference when I reverse its sign. So that's 3k, 6 plus k, 0, 7, 7, 2k, 4, 3k plus 4. Now I want the transpose of that matrix, so transpose here. So the top row I'll write in the first column, so 3k, 6, 6 plus k. Second row I'm going to write in the second column, so 0, 7, 7. Then the bottom row I'll write in the third column, 2k, 4, 3k plus 4. Right, we're now ready to find the inverse of A. That's 1 over the determinant. Now, way back at the beginning, we worked out the determinant is 7k times by CT. So that's going to be 3k, 0, 2k, 6, 7, 4, 6 plus k, or k plus 6, 7, 3k plus 4, or 4 plus 3k. There we go. Now, if we wanted to, you could write every element over 7k. I probably wouldn't bother, but you'd get something like this: 3k over 7k, 0, 2k over 7k. I mean, I suppose then you could cancel the k's out, couldn't you? 6 over 7k, 7 over 7k, 4 over 7k. So you just write every element over 7k. So this is an option. 7 over 7k, and then 3k plus 4 over 7k. So this is an option to write it like this. And then what happens, some of them will cancel down. So for example, this first one here will become just 3 over 7, 2 over 7. What else will cancel down? That will just become 1 over 7, 1 over 7. Yeah, nothing else really sort of cancels down. Oh, yeah, so you'll have to leave the rest like that. So that is an option. Right, okay, the matrix A is that, and the matrix B is such that A, B inverse, all inversed is that. Show that A inverse equals A. Right, so the way we're going to do this, sort of if we think about this sort of logically, we want to show that A inverse equals A. Now, what would happen if we multiplied both sides of that by A and put A at the front? So you've got A inverse, times in both sides by A, but A at the front of both sides equals A times A. Okay, now another way of writing A times A, you could write that as A squared. But what do we have over here? Well, anything times its inverse is the identity. So basically, if I can show that A times A, or A squared, equals the identity, okay, the identity matrix, which is 1 0 0 0 1 0 0 0 1, then I've proved that statement. Okay, so let's do that. So we're going to take matrix A and times it by itself, which is probably a lot easier and quicker than trying to work out the inverse. So when you get statements like that, think about what you can do to that statement, multiply it by something to make it an easier statement to prove. So I'm just going to write out the matrix again. 0 1 0 1 negative 1 2, and so let's multiply them. So the top row multiplied by the first column, so I'm going to do that times by that to get the first element. So that's going to be negative 2 times by negative 2. So that times by that, which is 4. 4 plus 0 minus 3, which is 1. That's a good start. So 1 there. Okay, let's move to the second column, first row. So I'm going to do this row here times by this column. So negative 2 times by 3 is 6. 6 minus 3, negative 6 plus 3 plus another 3 is 0. Right, moving on. If we get to first row, last column, so here that's going to give me 6 plus 0 and then minus 6. 6 minus 6 is 0. So this is looking good so far. So next row, so second row, first column. So that's going to be this row here times by this. So 0 plus 0 plus 0, so we get 0. Moving across to the second column here in the first row. So 0 times by 3, 0. 1 times by 1, 1. And 0. So it's looking very good. And moving on to the last column in the second row. So 0 times negative 3, 0. 0 and 0, so we get 0. So unless this all goes wrong, it's looking good. Right, so bottom row, first column. So we get negative 2 plus 0 plus 2, so negative 2 plus 2 basically is 0. Moving on to the second column on the bottom row, so we get 3 minus 1 minus 2, which is 0. This better be 1, otherwise we're in trouble. Negative 3 plus 0, negative 3 and then plus 0 plus 4, so negative 3 plus 4 is 1. Okay, so the statement has been proved as required. In part B, it says find the inverse of B. Right, now if you think about it, we've been given this statement up here, this one, that the product or the inverse of the products is that, and we know that A equals its inverse, and we want to find B inverse. So can we use that statement and the fact that A inverse equals A to work out B inverse? Yeah, rather than trying to do some other method. So let's start with the statement that we've been given, which is A, B, product of that equals that. Now remember, in a previous section, we prove the statement that the inverse of the product is equal to the product of the inverses. But remember that these letters change order like that. So basically what we want to get at is this: can we, either on this side or the other side, can we write some sort of statement where we end up with B inverse equals something and something that we need to do to A. So because we want to get rid of this A inverse, what we're going to do is we'll multiply both sides by A, but A at the end. So we're going to put it at the end of both sides. So we've got AB in brackets inverse times by A equal to B inverse times by A inverse times by A. So this is the thing that I've multiplied. Whoops, let's get a highlighter. This is what I've multiplied both sides by. Okay, now we know what's going to happen is that this will become the identity, which they sort of cancel out. So then what we're left with in the next step is A, B inverse A equals B inverse. Now that shouldn't be too hard because we know this. Yeah, that was what was given up here. And we also know A. A is basically right back at the start of the question. So let's do an arrow that goes all the way around here. There's A. So to find B inverse, we just need to multiply these two matrices together. So B inverse, which is what we're trying to find, is equal to AB inversed. So that's going to be 8, negative 17, 9, negative 5, 10, negative 6, negative 3, 5, negative 4, times by, and you must keep the order the same, negative 2, 3, negative 3, 0, 1, 0, 1, negative 1, 2. So all we've got to do now is to multiply these two matrices together. Let's see what we get. So starting first row, first column, we're going to have negative 16. There's nothing there. So negative 16 plus 9 is going to be negative 7. Top row, second column. So we're going to have 24 minus 17 minus 9, and that's going to give us negative 2. Moving on to the third column and the top row, that's going to give us negative 24, nothing from those two. So negative 24 plus 18 will give me negative 6. Middle row, first column, so we'll just work that out. So that's going to be 10, nothing, and negative 6. So 10 minus 6 is 4. Moving on to the second column. So this row and this column, so it's going to be negative 15 plus 10, which is going to be negative 5 plus 6, that gives me 1. Now third column of using the middle row, so that's going to be that times that, which is 15, 15, 0, 15 minus 12, which gives me 3. And we're on to the last bit now, bottom row. So we have 6 here, 6 minus 4 will give me 2. Bottom row, second column. So that would be -9 plus 5, which is -4, and then plus 4 is 0. Very last one now, bottom row, last column. So that would be 9, 0, and then 9 minus 8, which will leave me with 1. So that would be our final answer for what B inverse is. So we used some information that was in the question to help us find B inverse, and basically what we said was, right, we just want to make this like the subject of that expression. Yeah. Right, you should now be able to do exercise 6C on pages 115 to 116 of the textbook.